In this video, we're going to look at solving polynomial equations by factoring. Our first step is going to be looking at the polynomial and deciding how it should be factored. The polynomials that we will have in this section will be third degree polynomials, cubics. We'll have a mix of some that are 4-term and 1 or 2 that are 2-term polynomials, binomials. Our second step will be to factor the polynomial. If it's a 4-term third-degree polynomial, what we're going to use is the grouping method. If it is a binomial, we're going to look at the method for factoring the sum or difference of 2 cubes. The third step will be to set each factor equal to 0 and solve. Now, we will wind up with one factor that is a quadratic, okay, and then one factor that will be linear. The linear factor, of course, we'll just go ahead and solve, and then the quadratic factor, we'll need to use one of the methods that we looked at in section 1.3. Typically, either factoring or using the quadratic formula, whichever one you prefer, okay? So let's get started with an example. The 2 examples that I have chosen are actually 2 homework problems. Let's get a new page here. This first example, if you look in your homework from section 1.4, it's actually number 12, and it is x cubed minus 4x squared minus 2x plus 8 equals 0. You'll notice in the homework that there's more 4-term polynomials than there are 2, okay? The one on test is going to be a 4-term like this one, but I am going to go through a 2-term binomial in just a second after I finish this one to show you how that's done in case you run into it on WebAssign, okay? So when we factor by grouping, what we do is we make 2 groups of 2 terms. Typically, at least with this book anyway, you can group them together as the first 2 terms in one group and then the last 2 terms in a second group. For some 4-term polynomials, you have to reorder it before you can get the groups to work out correctly, and I'll show you what I mean by correctly as we go through this, okay? Factoring by grouping, we take the first 2 terms and put them in a group with a parentheses. And then what I usually do here, I don't go ahead and factor out that negative. Some people do that in this step, and that's fine if you want to do it that way. I go ahead and take a step where I just put a plus between the 2 groups, but be sure you've got either a plus or minus between them, okay? And if you do decide to take the negative out at this step, be sure you factor it out of both of those terms, the negative 2x and the 8, okay? I'm going to do that in the second step. What we do next is we find a common factor for both. All right, so that's going to be the x squared in this first set, leaving me with an x minus 4. And then again, I'm going to take that negative out in the second one. You can always tell if you're going to need to take that negative out if the, what's technically the 3rd term, I guess here, or the 1st term of that second group has a negative on it. You will be taking it out in this step, okay? So it's going to be a negative 2 that comes out there. And what you want to see happen here is you want these 2 groups right here to be the same. You want those 2 binomials to be equal to each other, okay? So what we've done, we've just taken a greatest common factor out of each group. At this point, the greatest common factor becomes that binomial, okay? So I'm going to take the x minus 4 out of each one of those 2 terms. So I'm factoring out a binomial here, okay? And then I write what's left, x squared minus 2 equals 0, okay? So that's the grouping part, all right? And if you didn't quite follow all of that, you may want to stop and rewind and look back through the grouping, okay, just so you understand how all of that goes. We're going to continue on here. Let me pan down a little bit so I've got a little more room. Now, we've got it factored, so what we do next is we set each factor equal to 0 and we solve them, okay? Now, sometimes you'll be able to take the second degree, the quadratic factor, and factor it again, okay? You can either do that or you can use, in this particular case, since it's a binomial, the easiest and quickest way to do it would probably be by doing the square root property, okay? And I didn't mention that before because I didn't think about the ones that you have to do like that. I was thinking about the ones that we get from the not perfect square, but the, the sum and difference of two cubes winds up giving you a trinomial quadratic, and I was thinking about those when I was talking about it earlier. You do wind up using the square root procedure when you're solving through these. So go ahead and set my x minus 4 equal to 0, and I can go ahead and find that answer, okay? And then we do the x squared minus 2 equals 0. And as I said, you can use the square root procedure. So move the 2 over, getting your squared term on one side by itself. Then take the square root of both sides, just as we did in 1.3. And don't forget to use the plus or minus, okay? So x is going to wind up being plus or minus the square root of 2. You can double check that if you want to by plugging those back into x squared. All right. So we actually have 3 solutions here. We have the 4, and then we have a positive square root of 2 and a negative square root of 2. And as you can imagine, for WebAssign, you have to write all of those separately. Okay. So WebAssign's version would look like this. There'll be a box. And you'll just type them in whatever order you want to. 4, negative square root 2. Be sure you move out from under that square root when you do the comma. And then square root of 2. Okay? All right, so that's one that you have to factor by grouping. Let's look at the sum or difference of two cubes. Now, the formula for this one, if you need to look at it, you can find the formula for the sum or difference of two cubes in section P4. Okay? All right, there's a formula in section P4 for doing this, okay? So this is what it looks like. If your sum or difference of two cubes, and we're just using the A and the B as sort of placeholders here. I'm going to use the sum version first, okay? The difference version works basically the same. That's going to factor into the sum of the cube roots of those two values, okay, whether they're variables cubed like I've got here or if they're numbers, times the square of that first term that you got in the little binomial, which would be a squared, the opposite sign from this one, which is going to be a minus, the product of those two, the product of those two terms in the binomial, a times b, the same sign, sorry, I keep forgetting to switch colors back, the same sign, and then the square of the last term. And there's a little mnemonic for this. It's square the first, opposite sign, product, plus square the last, SOPs. Okay, you've probably heard something similar to that whenever you've done the factoring of the sum or difference of two cubes before. Okay, if you want an abbreviation for the first little binomial, if you need something to kind of help you out there, you can use CSC, cube root, same sign, cube root. Okay, and that refers back to the original little binomial that we have there. Okay, now if it's a difference, it's actually the same type formula. So let me just show you that real quick. A cubed minus b cubed is going to be cube root, same sign, cube root, okay? And then pulling from the binomial, square the first, opposite sign, product, plus square the last. And notice that second sign there, that plus is always a plus. It doesn't matter what you have in the original binomial, whether it's a sum or a difference. Either one doesn't make any difference, okay? So this is a little formula we use. Let's do a real quick one, a quick example. This again is from the homework. I think it's number 16. X cubed plus 8 is equal to 0. So if we reference this to that formula, this would be our a cubed, and this is our b cubed. Okay, 8 is a perfect cube. It's 2 cubed. Okay, So we can factor that fairly easily using the little cube root, same sign, cube root, times square of the first, opposite sign, product, plus square of the last. Okay, so what we really need to do is figure out what a and b are. Okay, so if a cubed is x cubed, what would a be? It's just going to be an x, right? We just take the cube root. Okay, so that's going to give me an x plus, now what's the cube root of 8? We talked about the fact that 2 cubed is 8, so the cube root of 8 is 2. All right, and then we just use the little binomial we just created, so a squared would be x squared, opposite sign, product, 2 times x, plus square of the last, which is 2 squared, that's 4, okay? This is still set equal to 0. Now that I've got that factored, I have to set my factors equal to 0 and solve. Well, it turns out with the sum or difference of 2 cubes that this trinomial that you get right here is not factorable, okay? You will have to use the quadratic formula on it, or you can complete the square if you'd rather, if you find that that's a little easier for you to do. Either way is fine with me. I'm going to go ahead and find my answer from the little binomial. Okay, and then what we can do is and remember we're switching gears here, we're changing this to the quadratic formula, okay? So I'm going to define a as the coefficient on x squared, b is the coefficient on x, and c is the constant, all right? And you remember our little quadratic formula, x equals negative b, plus or minus, whoops, sorry, got ahead of myself there, plus or minus the square root of b squared minus 4ac over 2a, okay? And this is something that was missed quite a bit on the test, so y'all need to give this a little bit of practice because you will find that it's useful to you, okay? So let's go ahead and work through this, or at least write it down first. Negative b's already negative, so that's going to make that a positive 2, plus or minus negative 2 squared is 4, minus 4 times 1 times positive 4, sorry, over 2 times 1. So that's everything plugged in. Now we just start working through it. X is equal to 2 plus or minus the square root of 4 minus 16 over 2. This one's going to be imaginary, you'll see, okay, because we're going to get a negative under that root. Clean it up a little bit more. 2 plus or minus the square root of negative 12. And negative 12, that's not a perfect square, but 12 is, or rather does, have a perfect square factor, okay? So I'm going to kind of work this, well, we can do it as we can do it in line here. Whoops. Two plus or minus. All right, the I is going to come out, right? And then I've got 4 times 3 for 12 underneath. 4 is the perfect square factor. The I is already out. 2 plus or minus 2i. Okay, because I take the square root of that 4 as I bring it out from under the root, leaving the 3 underneath. And now you'll notice, first of all, it's imaginary, so we do need to split it into 2 pieces. But second of all, we've got a common factor of 2 here, okay? So you can either reduce it by 2, and as you do that, it will split into 2 pieces, or you can make 2 fractions and then reduce them separately, okay? And the way I was doing it in class is making the 2 fractions and then taking a step to reduce it. So I'll go ahead and do that same thing here, okay? The 2's will cancel, leaving me with 1 plus or minus I on the square root of 3 over 2. You can also tuck that I behind the square root of 3 over 2 if you'd rather have it that way, that's fine. Bring it down out of the numerator and put it just behind the fraction, letting the fraction be the coefficient, or you can leave it as is. That's your second and third answers, okay? So we had the, get back up here to it, we have the negative 2 for one answer, and then the other 2, well, shoot, sorry. The other 2 are down here in 1 plus or minus I on the square root of 3 over 2. And again, on WebAssign, you just need to type them in separately, okay? All right, that's it for solving the polynomial equations by factoring.